Hi, I'm Carol Wilson, Editor-at-Large for Light Reading, and I'm here with Cengiz Alaettinoglu, CTO of Packet Design. Welcome, Cengiz.
Thank you, Carol.
First of all, tell us what Packet Design does.
Sure. We are an analytics company for IP MPLS networks. We've been around for more than 10 years, and our customers range from service providers of any size to government organizations and large enterprises and so forth. We, in real time, collect telemetry data from the network. This includes the topology, traffic, the performance data, as well as the services running on top of the network.
Okay.
As a result of this, we know how much traffic is in the network, where it enters the network, where it exits, whether it's going to Google or Facebook, what path it took across the network, what kind of performance it saw, delay, or whether it hit any congestion. And our customers use this for various purposes. Number one being the diagnostics of the issues that happen in the network, or they may actually model a change in our tool and then see the impact before actually doing it in the network.
Oh, okay.
But ultimately, they use it to make better routing decisions that gives them, for example, savings in transmission costs. Now we are adapting our solution to software-defined networking.
Okay. So what challenges are you seeing in the wide area network?
The networks are becoming increasingly more complex, and basically they are becoming multi-services. And for example, during the day in a service provider network, you may see enterprise traffic. At night, it may be video streaming. Enterprise traffic as well and the video streaming have conflicting requirements. For example, enterprise traffic, you cannot drop any packets, whereas video, you can drop, it will adapt, and so forth. Optimizing a network for one service was already challenging. Now trying to optimize simultaneously for all of these requirements is very hard, potentially impossible by humans to do. Of course, the software-defined networking comes to rescue here.
Okay.
The other challenge that I see is rate at which the service providers need to change the network, the provisioning and unprovisioning of the services. And we are talking about machine-to-machine communication and how little time they have to provision these services. Again, this calls for automation. Again, software-defined networking comes to rescue here.
Okay, so what is Packet Design's approach to SDN? What are you doing in that area?
Good question, Carol. We talk to many of our customers, and what we hear from them is that they want pluggable module and RESTful APIs. We are going to be one of their vendors, and they're going to have different vendors. They may have homegrown tools, and they're going to use the data from each of these modules, and then they're going to come up with their own solutions. So as a result, as seen in this diagram, we are actually building a Packet Design service assurance platform. At the bottom of the diagram, we have the physical and the virtual devices in the network. This may include the NFVs. On top of that, we have the controllers. We don't believe one controller will rule all. It will be quite a few controllers. Some may be in the wide area, some may be at the edge for purposes. On top of that, we have our telemetry system. We are monitoring both the physical and the virtual devices in the network, as well as the controllers. We know what's happening in the network. We know what the controller is asking to do the network. From this, we come up with the real-time models of the network, the topology, the performance, and traffic. And using the past data, we come up with the predictive future values as well. For example, if an application was to request certain amount of bandwidth tonight, we know the expected level of traffic tonight. Real-time is very important, but predictive future analytics as well, very important. We have an optimization module that recommends good paths in the network. There is a big policy component, what an application can do in the network, or when resources are constrained, which application needs to be honored before the other applications. The top layer of this architecture is the open RESTful APIs. On top of that, we are going to write our own applications, from traffic engineering to bandwidth on demand to risk mitigation. But more importantly, our customers will write their own applications, and there may be third parties who may be writing their own applications as well.
Okay, so tell me about your SDN traffic engineering application.
Sure. It's actually a classical workflow, traffic engineering, and service providers use that to find available bandwidth in the network, available capacity, so that they can delay capacity investment. With the multi-services, it becomes harder to do this because of this conflicting requirements from different applications. And we took that workflow, we simplified it, and we made it capable for multi-services. We actually enhanced what the engineer can do with this particular workflow. Our application actually finds underutilized links and then pushes the traffic there. This obviously does CapEx savings for the service provider.
Right.
But because it's a simplified software workflow, it also saves OpEx because the engineer doesn't have to spend as much time trying to run this application. And ultimately, the path that we recommend is provision using the controllers such as OpenDaylight or ONOS or whatever.
Okay, interesting. So you're really getting the most efficient use possible of the available network.
Exactly.
Okay, that makes a lot of sense. What's unique about your SDN solution?
Ultimately, we are a turnkey solution because we have the 10 plus years of this telemetry expertise. We know everything about the network as well as the algorithms. When you put that together, it really provides the foundation for any SDN solution. We have every component that you need to build these applications. Also, when software is making decisions that traditionally engineers used to make, the software needs to be powered by the same know-how. Otherwise, you will actually change the network and then you will actually get unforeseen consequences, and then the application performance will suffer and so forth. For the 10 plus years, we've been powering engineers with the analytics that actually made them do this job. Now we are using the same analytics to power software to do it. And we are also the only vendor-neutral solution for wide area networks.
Okay, so this is part of this whole push to automate processes as well as virtualize them, so that at the end of the day you wind up with a solution that's more automated on an end-to-end basis.
Absolutely.
Okay, that makes a lot of sense. Cengiz, thanks for being here with me today.
Oh, pleasure. Thank you.